So we've got these AI agents that are frankly brilliant. They can pull off some absolutely amazing feats. But, and here's the catch. Right now, a lot of them are like these geniuses working in total isolation. To really unlock their true potential, we have to build a society for them. A way for them to find each other, talk, and actually work together. So what does the architecture for that really look like? Let's dive in. And that right there is the big question, isn't it? How do we go from this world of powerful but totally disconnected AI tools to a real collaborative ecosystem? One where autonomous agents can delegate, negotiate, and solve huge problems, all on their own. Okay, so the very first step in building this AI society is breaking them out of that isolation. We need to give them a way to just find and introduce themselves to one another. And this brings us to the first crucial piece of the puzzle: horizontal communication. Think of the agent-to-agent protocol, or A2A for short, as the social etiquette for AIs. It's basically a standardized language that lets one agent find another one, figure out what it can do, and then ask it for help, all without a human needing to step in. So in this new digital world, how does an agent make a first impression? Well, not with a handshake, but with the next best thing, an agent card. You can literally think of it as a professional business card, but for an AI. It tells any other agent everything it needs to know, right at a glance. And the real beauty of this idea is just how simple it is. The agent card is nothing more than a standard JSON file sitting at a predictable web address. It's an open, public resume that says, here's who I am, here are my skills, here's how to reach me, and, this is critical, here's how we can have a secure conversation. And this simple flow is pretty much the entire social ritual for these AIs. First, one agent discovers another by reading its agent card. Next, they do a secure digital handshake to make sure everything's trustworthy. And only then do they actually start talking, passing tasks and info back and forth. It's really just a digital version of meeting a new colleague for the first time. But what about a really big task, right? Like write an entire application. A standard web request would just time out. It would give up. And this is where the A2A design is so clever. It uses a subscription model. So instead of one long, silent wait, the agent that asked for help gets a continuous stream of updates. Okay, I'm starting. I'm writing the first file, all the way to, okay, I'm done. It's just a much, much more robust way to handle those complex, long-running jobs. All right, so agents can talk to each other now. That's huge. But what about the tools they need to actually do their jobs? Accessing a database or a file system. Well, that needs a whole different kind of connection, what we call vertical communication. And honestly, the best analogy I've heard for this next protocol is the USB-C for AI. Just think about how USB-C got rid of all our different chargers and cables and gave us one standard that just works. That is exactly the goal here, but for AI tools. It's called the Model Context Protocol, or MCP. So while A2A connects agents to other agents, MCP connects an agent to its tools. Its main purpose is to completely avoid vendor lock-in, creating a universal plug-and-play standard so that any AI can use any tool without needing a custom-built integration for everything. Now, this architecture has three main players. You've got the host, which is the app the AI is running in, like your code editor. You have the client, which is the bit of logic inside the AI that speaks the MCP language. And then you have the server, which is the actual tool itself, like a Google Drive or GitHub server. And this separation of roles is the absolute key to its flexibility. Okay, but this brings up a pretty obvious question. What happens when an agent needs to do a bunch of stuff at once, like access files, send an email, query a database, and post to Slack? Does it really have to manage dozens of separate connections? Because that would get messy fast. And the answer, thankfully, is no. And that's because of a really clever design called the hub pattern. You have this virtual server that acts like a universal power strip. It plugs into all the individual tools, GitHub, Slack, whatever, and then presents them to the AI agent as one single, unified catalog of skills. The agent only has to manage one connection, which makes everything so much simpler. So we've got protocols for agents to talk to each other, and protocols for agents to use tools. But what are the actual wires and highways that carry all these messages? This is the transport layer, and believe me, the choice you make here has a huge impact on both performance and security. The two main options here give you a really clear trade-off. For connections on your local machine, STDIO is perfect. It's super fast, super secure, and there's basically zero setup.
The catch? It can't leave your computer. For remote connections over the internet, server-sent events, or SSE, are the way to go. They're great at getting through firewalls, but they do require a bit more setup to keep things secure.
But what if you need absolutely top-of-the-line performance? I'm talking about a swarm of agents in a data center for high-frequency trading, where every single millisecond counts. For those kinds of extreme cases, standard web protocols just aren't going to cut it. You need even more specialized wiring. So let's quickly look at two of the heavyweights. On one side, you have gRPC. Its whole philosophy is about a strict contract, which means communication is super structured and predictable. That makes it fantastic for stable, reliable systems. On the other side, you've got ZeroMQ, which uses smart sockets. It's way less rigid, giving you unbelievable speed and flexibility. It's perfect for internal agent clusters where raw performance is the only thing that matters.
So, let's pull all these pieces together. We've talked about how agents talk to each other, how they use their tools, and the wires that connect everything. What does this new AI architecture look like when you put it all together? Well, it really all comes down to these key pillars. You've got horizontal communication with A2A, which is how agents socialize. You've got vertical communication with MCP, so agents can use tools. And underneath it all, you have the transport layer, the wiring. But the single most important idea here, the core principle, is decoupling. By keeping these parts separate, the entire system becomes flexible, modular, and ready for whatever the future throws at it.
And this really brings us to our final thought. These protocols, they aren't just technical specs. They're like the constitutional laws for a brand new society of artificial intelligence. And it leaves us with a really fascinating question. What new possibilities, what new industries, what new forms of creativity are going to emerge when millions of specialized autonomous agents can finally collaborate as easily as we can? The architecture is being built right now.